Hello, good evening, everyone, and thank you for joining tonight's AeHIN Hour webinar. Please note that all microphones are muted throughout the meeting, and for comments, please use chat. For questions, please use the questions box. Tonight's speaker is Mr. Ryan Crichton, who is a lead developer at Gemby Health Systems and has been leading the development of the OpenHIM and HEARTH tools that are developed and used by Gemby Health Systems. So to learn more about it, here is Sir Ryan.
Hi, everybody. Sorry for keeping everyone waiting today. I just had a little bit of trouble getting everything set up on my side, but I'll share my screen and we can get started. All right, is my screen coming up correctly?
Yes, sir. Thank you.
Great. All right. Yeah, thanks everyone for joining. So today I'm going to be talking a little bit about HEARTH, which is an emerging FHIR server that we've been working on here at Gemby Health Systems. So just to start off, my name is Ryan Crichton, as I was introduced earlier. I'm a lead developer with Gemby Health Systems. Been working on a few of the interoperability tools at Gemby, the OpenHIM and HEARTH being the major two that are generic. And today I'm going to be talking about HEARTH, which we've been, it's really still pretty new in terms of development, but we wanted to share it with the community and just share what we've been doing in the space and get feedback. All right, so firstly I'm going to start a little bit about what is HEARTH. So HEARTH is a generic open source FHIR server. So FHIR is a base standard, which we'll talk about in a second. The point of HEARTH is really to be a tool that implements the FHIR specification, which enables a new set of, or new paradigm for interoperability, a new way of doing interoperability between health information systems. So like I just mentioned, it's in pretty early stages of development. There's no formal stable release yet. It's a tool we've been working on internally. But that being said, we've also been using it in some of the projects that we've been currently working on at Gemby Health Systems. And some of those are starting to go towards production. So we do see the code as fairly stable, but not quite at the stage where we'd want to see it fully released. But it is open source, and it is there's a space to contribute to help us get it there. So it's also, apart from just being a generic FHIR server, it's also designed to support certain FHIR-based IHE profiles. So IHE is integrating the healthcare enterprise, and they release a number of profiles that are designed to ease interoperability challenges for particular purposes. So some of the profiles that we support within HEARTH are MHD, PIXM, PDQM, and soon to be supported as MCSD and MACM. I'll talk about those a little later in the presentation, so you can get an idea of what those do and how those can be used. The other thing that we support is resource matching. So what this allows you to do is within within the HEARTH server, you can match resources against each other and so you can say, I want, for example, a patient where the name is John, surname Smith, with a particular date of birth, and we'll try to match that against what exists in the database and return the matching results to you with a score. So that's another thing that we're trying to do, but not just for patients, for any resources that are within HEARTH. Although this is fairly basic at the moment, we'd like to expand it to be a little bit more fully featured. But we do have some of the basic support for resource matching built in at this early stage, and we'd like to see it sort of expanded. So to summarize, HEARTH is really just an open source FHIR server that we saw the need to build a new FHIR server because we wanted to support some AeHIN standards that some of the other open source FHIR servers don't support or don't choose to support as a feature of theirs. And we also wanted to do some basic matching within resources, which is a little bit outside of the plain FHIR specification. So that's sort of the justification of why HEARTH exists, and what we saw as missing, and why this is an opportunity for us to build something new. Okay, so to understand what I mean by saying that HEARTH is a FHIR server, I guess we need to understand what FHIR actually is. So FHIR stands for Fast Health Information Resources. It's basically a new base interoperability standard for healthcare, whereas previously we'd used standards such as HL7 v2 or even HL7 v3, which were standards that are pretty widely used in some parts of the world for healthcare interoperability. FHIR is sort of taking the lessons learned from those and trying to apply them to more modern technologies. It revolves around defining a number of healthcare-related resources. A resource is really just like an object, so a patient or a practitioner or a location are all examples of resources. And then the FHIR spec describes how those resources can be interacted with, so to create them, to update them, to delete them, and how you do all those interactions programmatically. So it basically it uses a simpler and more modern technology that we're more familiar with nowadays, rather than the older style base standards like HL7 v2, which just used plain sockets and sort of a custom messaging format. This uses something that developers nowadays are more familiar with. So it uses a RESTful API, and it supports both JSON and XML as a transport format for the actual messages themselves. So that's fairly common for developers of this age that would be familiar with those sorts of technologies. That's how a lot of other APIs are built. So this is trying to really bring standardize a healthcare API using these more modern ways of doing things. And the benefits of that is that it's easier for modern developers to get to grips with using these newer technologies. A REST API with JSON and XML is a lot simpler for most devs to understand and get to grips with, and is more familiar when coming from other types of domains other than healthcare, where this is quite common, a common way of producing APIs. So how does that relate back to HEARTH? So HEARTH really implements this FHIR specification. Well, more specifically, it implements a subset of the FHIR specification. The FHIR specification consists of a whole bunch of resources that you could go have a look at it on the FHIR website, where it lists basically every resource that can be described. So we support in HEARTH a subset of those, although in the future releases we plan to support as much of the FHIR specification as possible, so that could be expanded to support a whole bunch more FHIR resources. And then HEARTH also implements the sort of the core RESTful API that FHIR describes, so that you can create, updates, delete resources all via this single API. So that's really, HEARTH is an implementation of a FHIR server. Not a full implementation, it does a subset at the moment, but we're working to increase that as much as possible. And we have some pretty exciting new code that's going to land sometime soon that will allow us to support a large portion of the FHIR specification. Okay, so just moving on from then what are we trying to do with HEARTH, and more to look towards how it's architected. So HEARTH itself is an app built on Node.js. So Node.js is a platform that uses JavaScript on the server side. So this server is basically just a JavaScript application that runs on the Node.js platform that provides this RESTful API to be used. So if you look at the diagram I have here on the left, this is a simplified version of how HEARTH looks. So the box in the middle is HEARTH with a few components inside of it. It then talks to a MongoDB database. Sorry, it looks like the audio connection got lost and then resets. Is it? I seem to be working now.
Yes, hello, Sir Ryan.
Okay, great.
Thank you.
All right, so I'll continue. I don't know where it cut off, so I'll just start explaining the slide again. So this is just a base overview of the architecture of HEARTH. It's got a few components in the middle box there, which are within the HEARTH application. And then it talks to a MongoDB database at the back end. That's where we store all of the FHIR resources. And at the top there, you've got HTTP requests coming in. So those are requests from clients to either save resources or update resources, delete resources, fetch particular resources that they're interested in. All FHIR interactions come through as HTTP requests to the server. And then the core components within the HEARTH server are the four boxes in the middle there. So we have the core interaction handler, which really just handles, creates, reads, updates, deletes, history operations, all from the FHIR specification. Then we have on the top right there, the FHIR resource modules. So we have modules for particular FHIR resources that allows us to do custom handling of those resources. So a lot of the interactions or the resources we use can use a default module that they basically all handled the same, and we just store those to the MongoDB database without having to do anything custom. But some of them require some custom logic to be able to store those correctly. And this is where the FHIR resource modules come in. Those can be plugged in for any type of FHIR resource, and we can basically do some processing on a request as it comes in or as it's about to finish in those modules to help it do some custom logic. So for example, this could be a binary resource within FHIR, which just stores binary data. So we want to store binary data differently than we just store normal resources. So we have a custom FHIR resource module there to store binary data using GridFS, which is a different technology that we use to store that. But it's basically just an extensible mechanism to allow us to do some custom logic when handling particular resources. So it makes HEARTH quite extensible. So you can do some interesting things if you have some logic you need to run when receiving a certain kind of resource. For example, maybe when you receive a patient resource, you need to do something specific, or make a call to another system, or do some checks or validation for your particular implementation. That sort of thing can hook into FHIR resource modules. Then we also have below that a plugin architecture, which allows you to plug in, create a plugin file, which allows you to do certain, again, custom logic. So you can basically add a plugin that hooks around a number of resources and a number of interactions. So say I want to hook around any patient or practitioner resource updates. I can do that and then do some custom logic there just by creating a plugin file that's configurable and then adding custom logic to it. So this helps when you want to do some custom over multiple resources or multiple interactions. You can add a plugin that does that. And what this is often useful for is things like authorization. So implementing authorization rules, who has access to what resources. You can implement that sort of logic there. And doing other sorts of extensions where you want to make sure certain fields exist, or you want to do something custom to your implementation. So the whole idea with the HEARTH tool is that while it's still a generic FHIR server, there's lots of hooks in place to do custom logic so that it can work for your implementation and suits a variety of different needs while still being generic and following the FHIR specification. So the next thing and final component within the HEARTH architecture is the matching queue and worker. So this basically supports the matching of resources. So we have a matching queue. So basically anytime a resource is updated or created, we add it to the matching queue so that it over time it will be matched against everything else that exists in the database and see if there's a potential link between something that already exists. And this is an opt-in feature. You don't have to enable it, but it's useful for things like when you're creating lots of patients and there might be 2 patients' records that are created for the same patient. And this will help to catch that. It will, as long as your matching configuration is set up correctly, it will try to match the patient that you create with all other patients in the database and come up with the link if there's a match that scores quite highly. And I'll talk a little bit further about the matching later on, but you can set up what fields you wanted to consider during while doing matching. So that was a little technical, but basically what you need to take away from this is that HEARTH does implement the plain FHIR specification, but on top of that, it also implements mechanisms to allow for custom logic to be incorporated so that the FHIR server becomes more of an implementation-specific application, which can do some specific handling that you might require, and that it has some matching configuration and matching elements that help to perform matching that's over and above the FHIR specification. And all that is stored and persisted in the MongoDB database. Then the next thing that's useful about the architecture is that it's massively scalable. So we can run as many instances of the HEARTH application as you need. And it'll basically, you can set up some load balancing between them. They're all stateless and it doesn't matter which of those multiple instances a client interacts with, they'll all act the same. So that means it's easy to scale out over multiple servers and for large implementations. And the same goes for the MongoDB database, which is also massively scalable over a number of servers and can handle large number of reads and writes depending on what your implementation scenario is. So that was something else very important to us in designing this this application, is that it could grow to the scale that we need quite easily without having to just rely on one single massive server. We can spread it out over multiple servers as necessary. Also, the choice for choosing MongoDB is that it's very good at storing JSON data, and that's basically what FHIR supports. So JSON data can be stored natively and queried natively. Node.js, the platform on which HEARTH is built, is very fast, and not only fast in terms of performance, but it's also very quick to develop with, to add new features and to change. For us to implement new features into Hearth using Node.js as a platform makes it quite a lot faster than other similar technologies. And the final thing to note is there's no front end to Hearth at the moment. It's really just a server that you can use for interoperability needs. But there are a few front ends that exist for standard FHIR-based messages, which could hook into Hearth quite easily, as long as it just communicates within the FHIR standard. So that's also something that can be hooked in, and we might have some. We might be producing a front end at some point, but that's not on our immediate roadmap. Okay, so let's move on from architecture. Okay, so I know this group is fairly familiar with the OpenHIE pattern. So how does Hearth fit into OpenHIE? So you can see at the bottom here, I've got clients of a health information exchange with in the middle an interoperability layer that can route to various services that sit either at a national or district level or whatever it may be, depending on the health information exchange implementation. So we've got a client registry, a provider registry, facility registry, and shared health record. All of those could potentially be a Hearth instance. So because Hearth is a generic FHIR server, it supports a number of different interesting resources that could be used for a number of different domains within health information exchanges. So there's patient resources for a client registry, there's practitioner resources for a provider registry, there's location resources for a facility registry, and there's a variety of clinical resources for shared health records. So because Hearth is trying to just support the FHIR standard, it could be used for a multitude of these registries, or for just a single one if that's the only gap that you have in your implementation. So it's really designed to be pretty flexible. The choice of how you integrate Hearth into an OpenHIE-based health information exchange is up to the implementation. It could be you could have one Hearth instance that acts as all of these actors, a client registry, provider registry, facility registry, and shared health record all in one. Or you could choose Hearth to fulfill a particular role if you have existing services for the other components already. Or you could use multiple instances of Hearth to act as either a client registry or provider registry or facility registry. So there could be multiple instances of Hearth acting as each one of these components. It's really up to what makes sense for the implementation. There might be some useful, it might be quite useful to restrict an instance to only care about one particular domain so that you can have custom logic that handles particular things for that domain. Or it could be simple when you have limited time and limited resources to have a single Hearth instance act as all of these, which might make sense for smaller prototype projects or even some production projects where you don't need the complexity of having multiple of these. So in terms of in summary, how it relates to OpenHIE is really up to the implementation. It could act as a number of the components that we have already described within OpenHIE, but it doesn't have to act as any of them. It's really up to the implementation how you choose to use Hearth, or if you choose to use Hearth, really. Okay, so on to the next slide. So here I'm going to talk a little bit about the IHE profiles that we support. So one of our major reasons for building Hearth was some of the existing FHIR servers are really just try to act as a FHIR server and do nothing else. While we wanted to respect the FHIR standard, there are also a number of IHE profiles that make use of the FHIR standard as their base standard. In those cases, it makes quite a lot of sense to support those within a FHIR server and have those available for people that want to use the IHE profiles that have been set up. So we've tried to support as many of the ones that make sense, at least the ones that we've been using internally, and keep those up to date. So the first one is the MHD profile, which is mobile health documents. This is basically for storing and retrieving of clinical documents. So it's a FHIR-based way to store clinical documents about a patient and then retrieve those later. Then we also have the PICS-M profile. So that's patient identity cross-matching. The M stands for mobile, which basically means it uses FHIR, not the older HL7 version 2 messaging. And this allows you to query for alternative patient identifiers. So it's a cross-matching of identity, basically. So you can give it an identifier that a system that you know as a system, for example, a folder ID or something, and if you get the patient's national identifier back, that you can use as a client to store data against. So it's just a way of resolving identity between patients and their different identifiers. The PDQ-M profile that we support is for then querying patient demographics. So there's a set of patient demographics that we support and queries that we support to allow you to query for patients using a whole bunch of different demographic fields that the PDQ-M profile specifies. Those top three are the ones we currently support. The bottom two are ones that we've had contributed to us from the IntraHealth team. So IntraHealth has been doing some good work on getting MCSD and MACM into HEARTH separately from GEMBI Health Systems. And that's been great to see that we have some collaboration already from them. And they actually took HEARTH to the IHE Connectathon in January and passed the Connectathon on the MCSD and MACM profiles, which was quite exciting to see. But yeah, that code is about to land in HEARTH soon, but is not quite there yet. We're just getting that all included, and then it'll be into HEARTH properly. But that's sort of coming soon. MCSD is a profile for keeping interlinked data in sync. So interlinked data about providers, facilities, and services, and how all those link together. For example, which providers work at what facilities and which services do they provide at those facilities are the type of data that CSD tries to capture. And MCSD is the linking of that to the FHIR standard. And we support the resources that are involved in those profiles. And then finally, the MACM profile, which supports communication resources. So this is for being able to support resources that allow you to specify alerts and read alerts and handle those within your system. It's all around communication and handling communication between different parties. Okay, so that's an overview of some of the IHE profiles that we support, and we'll hopefully be adding more of these as more of the IHE profiles get turned to FHIR, and that's kind of one of the key components of what HEARTH is trying to do. Okay, so the next feature I want to talk about is the resource matching. So like I said before, the resource matching, while the base resource matching exists, it's still a bit of a work in progress, but we've made some quite good progress in this light so far. Our idea is to try not just support a single resource like only matching on patients, but rather try to support any FHIR resource to be matched upon. So HEARTH can be set up to match on any of the resources that it supports. There's a $match operation within FHIR that basically allows you to query for results from a particular resource. So, for example, query all practitioners that have first name John, second name Smith, with a particular date of birth would be a type of matching operation. And what you would get back is a list of resources that were close to that, to what you specified, and with a score attached to tell you how close they were to that. And how we achieve that is by having the user, whoever wants to implement HEARTH, set up how they want the matching config to work per resource. So this consists of two types of configuration. The first is a discriminator query. So basically, the problem with doing matching is that you often have a really large database of people, say 1 million patients. You don't want to run matching algorithms against every single one of those patients, because that'll take an extremely long time, and probably you won't be able to get real-time results. So what you can set up is what we call a discriminator query. It's also called blocking in matching theory. It's called a blocking algorithm. So what this does is it allows you to determine a particular set of fields that you want to block on. So it'll basically reduce the search set that you want to search on to something more manageable. So let's say we want to search 1 million patients. We can set our discriminator query to say, before you even start doing any of the matching algorithms, the more intensive algorithms, rather just make sure that when we query for a person, if their gender doesn't match, then we discount them completely already. So if we're searching for a male, we discount all other genders, for example. Or if the first 2 letters of their surname doesn't match, discount them completely. So currently the default setup we have is just to have a discriminator query set up for that their gender must match, and that the first 2 letters of the surname must match to even be considered for matching. And then once that sort of reduces the search set from 1 million patients to maybe 100,000 or something, or maybe 50,000 or less. And that's more manageable to do a full search on and to actually get a score of how close the match is. So the next config that you can set up is a set of matching fields that you want to consider. So you can choose within HEARTH which fields you want to consider in a resource. So you can choose maybe first name, last name, gender, date of birth are often common ones. So you can choose those 4 and set up how those are matched. So we support only a few matching algorithms at this time, but it's easy to add more, and we hope to add more in the future. We support things like a double metaphone, which is a phonetic algorithm. So, for example, it'll get matches on names that sound similar. There's Levestein distance that we support, which is basically, it's a distance algorithm, which is a good indicator of typos. So if you're 1 or 2 characters off in a name, it'll basically be able to tell you that, and you'll be able to score off of that. So it's good at catching typos. And then exact and partial matches are also supported. So you can maybe say the gender must match exactly, but we can do a partial match on date of birth, for example, for just in case we're 1 or 2 days off on date of birth. So it's basically you choose the fields and you choose the algorithms that you want to match with, and once that's set up, the matching starts to function as you've configured it. Yeah, so that's basically how it works. So it's initial blocking query to get it down from a large search set to a smaller space to search, and then we do the more complex algorithms on the smaller search sets and come out with a list of results and scores attached to them that we can return to the user to say how close something was matched, or if there weren't any potential matches. So again, this is a work in progress, but we have some of the basics of this working, and we hope to expand on it in the future because we think can be pretty powerful given the correct implementation. Okay, so that's basically what I wanted to go through today is an introduction to HEARTH. The last thing to talk about is just how to contribute. So please, if you're interested, please try it out. You can find the code and also try it out on GitHub. So that will require you to install the server and get it up and running. But if you want to, that's available to you. You can also add issues and suggestions of things that you'd like to see right on GitHub. And if you're a developer, feel free to have a look at the code and contribute pull requests. If you're interested in advancing some of this, we're more than happy to accept contributions and have people contribute code that we can include within HEARTH to make it better. And finally, it's still in early days, but we think it's been useful in a number of our projects, and we'd be keen to see what everyone else thinks, and happy to answer any questions. So yeah, that brings me to the end of my presentation. I'd like to take any questions now.
Thank you for that presentation, Sir Ryan. I'm not seeing questions from our participants yet. To all our attendees, if you have questions, you can type them in the questions box. Thank you.
Great. So if anyone has any questions, they can type them in. Otherwise, I think that's all I have to say.
Are there any questions from our participants? I guess we can wait for a few more minutes just to see.
Sure, that's fine. I'm happy to wait.
Thank you. Oh, here's the first question, Sir Ryan. It's from Sir Derek. Ryan, is there a strategy for preserving content as the FHIR spec evolves?
Sorry, I didn't quite understand the question. Let me try to read it myself. Just trying to find the right place.
Ah, yes, can you see the questions box, Sir Ryan?
I can, yeah. Oh, so I think what Derek's asking is there a strategy to handle different versions of FHIR? So yes, that's something that we're actually working on at the moment. So we have supported up until now DSTU version 2. And we've been hand coding support for each of the resources within that. But some of the really cool, I think, work that we've been doing recently is to try to dynamically read the FHIR specification and build up queries based on the actual FHIR specification that is provided by as a FHIR download, and trying to generate queries like that. So what that gives us is the ability to support pretty much everything within the FHIR specification, as long as we're dynamically reading it correctly, without having to change much code on HEARTH itself. So you can imagine this working by you basically download the DSTU2 FHIR definitions, which are provided on the FHIR downloads page, provide those to HEARTH, and HEARTH immediately understands how DSTU2 works and supports all of the DSTU2 features. And the same goes for STU3. And the next version, STU4 or whatever, as long as those definitions are provided to us, HEARTH will automatically read those and support the newer specification, which I think is, because FHIR is a standard that's designed to evolve over time and not really ever be finished, then it really helps us with that. So we have some code related to that now. It's not finished yet. We're close, but we're not quite there. And also, it's basically the first thing that we're supporting is all the different query parameters that change from version to version, and some basic validation of the resources coming in for each FHIR version. But that can now be done dynamically, so that for future versions we can keep adding to this, and we don't have to change as much code as new versions come out, which is pretty exciting.
There is another question from Sir Derek. Sir Ryan, can content creating using one version still be available as another version is validated and is taken up?
Well, that is one. Technically, yes, but you might encounter some conflicts where things wouldn't quite make sense. So there's no automatic conversion between different versions, but a lot of the code will still work between different versions, even if you have old DSTU2 versions of resources within your database, and you're using a version of HEARTH configured for STU3. A lot of it will still work and be able to come back, but you might realize that we'll just return you exactly what was stored, even though it's a DSTU2 version. So you might see some discrepancies in the actual resources themselves. But we don't really have a good upgrade path of how to convert resources from older versions to newer versions, which is, I guess, something we'd have to solve, and probably something that needs solving in the greater FHIR community as well, I'd imagine. And I think the next question is sort of related to that as well.
All right. Are there any more questions from our participants? Please type in the questions box if you have any.
I see there was one question about what problems we faced. I'm not sure if that responder could just let us know about what particularly with developing HEARTH, or is there something in particular you had in mind there? In the meantime, I can answer the next question. So what content formats, content types does HEARTH currently support? So we support both XML and JSON content types. That's a new change to HEARTH. So basically what we'll do is on incoming requests, we'll convert any XML messages into JSON so that we can process everything in JSON on the server. And then we'll also, if you request something in XML, we'll do the conversion on the way out as well to support XML as well. So that's quite, that's been quite a neat feature to get in there. Great. I think that's the end of the questions.
Yes. I think there are no more questions left. So to all our participants, if you have questions, maybe you can just email us so we can connect you to Sir Ryan. Again, we would like to thank Sir Ryan for delivering this lecture to our participants. And we look forward to having you in our next webinars. Thank you.
Great. Thanks, everybody. It's been a pleasure letting everyone know about some of the work we've done.
Thank you.
Thanks all. Bye.